Well, welcome back, friends of Room 8. Following our lessons on compound interest, we are going to continue with financial applications of compound interest, but we're going to look at it a little differently in that we're going to start applying some of the Excel functions that are available to us that can make our work quite a bit more productive. So to begin with, go ahead and go on over to Student Drive B and find a new workbook. And the name of that workbook is Financial Functions 2017. And so there'll be a workbook over there with your name. Go ahead and get that and open it up. And if you want, go ahead and save it to your Dropbox, although you are welcome to keep it saved at my location. And then come on back and we will get started. All right, so hopefully you didn't have any trouble with that. And what you can do is take a look at it, and especially take a look down here at the tabs. And the one that we're going to begin with is called Present Value. But you'll also notice that I went ahead and included some of the work that we did in the previous lessons on compound interest because they are related. It's just that when we're trying to establish certain goals, trying to do some formulas that are quite a bit more complicated, and answer some financial questions, it's nice to be able to use some of these features that Excel provides to us, and so all the calculations can be done by the computer. So the first one we are going to start with is called the present value function. Present value, PV. And so, well, there's our little lesson goal right there. In this lesson, we will use the PV function to find the present value of a financial goal. So what we want to do is actually use this knowledge that we're learning here to help us in a real life situation, and that is that at some point you're going to want to have certain amounts of money available to you, whether it be to buy a car, go to college, or plan years down the road for retirement. And so it's important to know, how much do I need to start saving today to have a certain amount of money available in the future. And so we're going to start pretty simply. We're just going to start with a single amount like we did in the previous lessons for compound interest. And so we'll put a certain amount of money into an investment today and not make any changes to that money and just let it sit there and let it grow over a period of time. And then in future lessons, we'll go ahead and start making payments. So to begin with, let's just take a look at how this present value function works here. And so we've got it right here, the what they call the syntax of it, or it just refers to the arrangement or the order in which particular variables or elements of the function are placed. So it starts with an equal sign, and it'll be equals PV, and then with that parenthesis, and then we need to put in the rate. And we're familiar with that from our previous lessons. It'll be some percentage. And then NPER refers to the number of periods. And you will recall from our previous lessons on compound interest, we had all these periods that we used. So, number of periods and some commas. We'll talk about this. And then this future value here will be our financial goal, how much money we want to have in the future. And then as far as the type goes, we're not going to worry about that. Anytime you see these functions with these types of brackets like this, optional. And so for now, we won't worry about that. We're just going to leave that blank. So let's take a look at our first problem. I think that would be the best way to do this. You've got 5 of them to do here. But we'll go ahead and do the first one, and I think it'll help to just make it clear exactly why we're doing this and how it works. So let's take a look here. We've got Samantha. Wants to have $20,000 available for college 7 years from today. Her parents are planning to invest in a mutual fund, and they expect to earn 8% per year paid monthly. So there's that compounding period, paid monthly. So we're going to have to deal with that. Now, what amount of money do they need to invest today, or how much do they need to put into this mutual fund today to reach the goal of $20,000 in 7 years? So the first thing you should know is that it's going to be less than $20,000 because you're going to be earning all that interest, and it's going to be over a sizable period of time, 7 years. So let's take a look back before we go ahead and do this. What we did back in compound interest videos 4 and 5, where we had set up this compound interest table and we had placed formulas within our table to reference these locations for principal, rate, and time, so forth. So I went ahead and plugged in the values for this problem here involving Samantha. And so what her goal is, let's start there. In fact, what I'm going to do is split the screen here. And one of the things that I want to tell you is that why these functions are so valuable to us is that, you know, we could go through and utilize our compound interest table and try to figure out some things to answer this problem, how much money she should invest. And the thing of it is, though, is if we're looking at 7 years and we're looking at doing this monthly, well, how many periods would that be? Well, it'd be 7 times 12, wouldn't it? 84 periods. So it's a lot. And so I went ahead and did that. And you can see here they all are. I think the most that we used in the previous lessons was like 24. So, and this is just for 7 years. So it becomes large. But let's see if we can get close to answering this question using our old compound interest table. And so this is what you could do. And don't worry about doing this. You can just watch, or if you want, go ahead and follow along. It's the tab right next to present value here. So what I'm going to do is freeze these panes so that we can easily see the last period, period 84, when I start putting in some of these variables here. So you recall from previous lessons, the way to do that is to go up to, from home, you go over to view and freeze panes. And there they are right there, freeze panes. So now when I scroll, in fact, I think what I'm going to do, I'm just going to freeze at that point right there. So let's do that. I'm going to unfreeze and then refreeze there. I like that better. So now when I scroll, I can get all the way down to 84. And so at the, you know, Samantha's goal at the end of 7 years, the 84th period, is to have $20,000. And there it is. Now the way I did that is that I just kept doing a trial and error here. I went ahead and put in the time, which was 1 month divided by 12. And there's the 8%. And then I just started putting in numbers. I said, well, how about $15,000? What if I start with that? No, that's $26,000. So I don't need to put that much in today. How about $13,000? So I just kept doing this trial and error, trying to get this account balance here close to $20,000 to see how much I need to start with today. So it's just trial and error is all I'm doing here, which is generally not the most efficient way to do things. Let's try 11,500. I think that's where I ended up before. So that's real close, within about $100. So it looks like we need to invest about 11,500 today, given an 8% interest rate, compounded monthly for 7 years, and at the end of that period of time, we'd end up with $20,000. So we want to simplify that. And so that's what we're doing with these Excel functions. Present value. Present value referring to how much today do I need to put in the bank so I end up with some future amount of money. And our goal is to end up with $20,000. Well, let's take a look at how we do this. Equal sign. PV, present value. Now what's real nice here is that you'll notice that rate is in bold, so they give you these little indicators here, clues of what is to come next, and so we need to put the rate in. Now one thing that's very important when you're using these Excel functions is that we maintain consistency with our interest rates and our time, that we're talking about the same amount of time for a given amount of return or interest rate. So, well, let's just do it and you'll see what I mean here. So it's 8% per year, but we're paying it monthly. Remember that in that simple interest formula going back to when we started. When we give that interest rate, it's always an annual rate. So we need to convert it to monthly because we're paying it monthly. We're compounding monthly. So we're going to put in 0.08. You could also type 8% divided by 12. So that's the rate. And then we have to separate that with a comma to put in the next argument or the next element of this particular function. And so then you'll see that now NPER is in bold, so that's the number of payment periods. And we already did that calculation, number of payment periods. It's 7 years monthly, so 7 times 12 is 84. So we could put in 84 at this point, or we can just put in, to make sure we haven't made a mistake with our arithmetic, 7 times 12. And that will calculate those periods for us. And then we need to put in another comma. And then payment pops up. Now we're not doing payment. This would be if we were to make periodic payments like every month. And so right now we're just looking at a single amount invested for 7 years. So when we skip one of these arguments or elements here, then we have to make sure we at least put a comma in so that Excel knows that we're just skipping that. So we put in a comma and then we just kind of put this comma in as a placeholder for payment that we're not going to use for this lesson. And then next up is FV, future value. And our future value is this $20,000. That's what our goal is. So we're using this function to find a financial goal, and that is how much do we have to invest today to end up with $20,000. So I'll put in my 20,000, and as far as the type goes, we're just going to leave that blank, and that'll be okay. Excel will assume that we're taking the default, and then we can go ahead and put a parenthesis and press enter. Now you're going to see this number pop up indicating like a negative number in red, and the way that we could avoid doing that, that's just the nature of the way it does the calculation. But what we can do is come back in to our formula. Just come on back in, and to edit you can press F2. And so if we just make our future value negative, we can end up with a positive value. And then press enter again. So once again, that was just putting a little negative sign in front of that future value. So when it does calculations, it'll return a positive number. And there it is, $11,445. That's how much we would have to invest today, or Samantha would have to invest today, along with her parents, at 8%, compounded monthly, to end up with $20,000 7 years from today. So go ahead and review any of this video that you need, or ask me any questions to clarify any of this. And then go ahead and practice the present value function with the next 4 problems, which are very similar, some different amounts and different goals.